Last week we created a new visual model for understanding intervals. The model was sort of supposed to function as an ideal way of representing intervals on grid space. And what made the model so great is it had the ability to transform common interval structures into easily identifiable shapes. When we made this model, we decided to portray pitch along both a y-axis and an x-axis on our grid, while the staff might portray pitch along just the y-axis and meter along the x-axis. And this means that one of the sacrifices we made when creating this model is that it can never be used as sheet music, because in order for sheet music to depict or show a song, it needs to be able to show pitch as well as time concurrently. If this model can't be used as sheet music, what's it useful for? Well, it's actually really useful as an educational device to dissect the scale and show how different concepts in music theory relate to the scale. And in this case, today we're going to dissect the scale and show how harmonies are derived from the scale. The scale I'm talking about is the same scale I've been talking about in every other one of the videos I've made. It's the scale that most Western music is based around. It's called the major scale and it sounds like this. To represent the pitches of the scale on the grid, we're going to use solfege. So, for example, and pardon my amateur singing, do, re, mi, fa, sol, la, ti, do. We're going to give each one of those pitches a distinct name. We're going to begin by building our scale by putting our pitches next to one another. So, of course, starting with do, re, mi, fa, sol, la, ti, do. When we align our pitches one by one, we get an image that looks like this, that I've seen images kind of a lot like this in one shape or form on the walls of elementary school classrooms. And to be honest, every time I see this kind of a shape, it sort of makes me cringe because it doesn't really represent space properly. Everything looks like it's one semitone apart. You can't really tell which one of these solfege syllables is two semitones apart. So the first thing I'm going to do is I'm going to change it so it accurately represents space. Spreading the notes out like this doesn't just help us understand when two pitches are one semitone apart or two semitones apart. It actually makes it possible to tell when pitches are any number of semitones apart. 6, 7, 8, 9, however many semitones apart they may be. If we don't visually depict sonic space in an accurate way, it's impossible to tell the size of the intervals we're working with. The second modification that I want to make to our image is I want to base it around re. And the reason I want to base our image around re instead of around do is I've found that re has a tendency to create a lot of symmetries, and if we're working with a visual model, it's a little bit easier to learn and see patterns on a symmetrical model as opposed to an asymmetrical model. This is going to seem really, really strange to people who have studied a fair amount of music to base your images or base your concept of the scale around re to re as opposed to do. But if you bear with me, I think you'll see over time that there's a lot of advantages in doing it this way. Re is the most symmetrical note in the scale. The way we know this is if we turned our scale into a circle and we decided that we were going to focus on just one of these exact notes, the only note that we could focus on and get a symmetrical image or a mirror image would be re. Any one of these other notes to focus on would give us an asymmetrical image. This doesn't mean that we have to always think of the scale as re to re. We can still think of it as do to do. It just means our background image that we're looking at while we're thinking of the scale as do to do should be re to re. Our final part of the process of depicting the scale on a grid is the same thing that was the subject of last video. So if we're representing along the y-axis our scale with each new segment of the grid equaling one semitone, now we're going to extend the same image along the x-axis with each new segment of the grid equaling 4 semitones. Our final version should look something like this. This could take up as much graph paper as we want, but I've decided to keep it relatively small for now. This ends up being a really, really good image for understanding harmony. Let me show you how you can use it. basic Western harmonies are created by taking a scale and playing every other note. So, for example, if our scale starts as in do, re, mi, fa, sol, every other note would be do, mi, sol. And our chord would sound like this. Do, mi, sol. And of course you can do this with every note in the scale. So I could also start with re, and instead of going re, mi, fa, so, la, it would be re, fa, la. And it would sound like that. What's great about dissecting the scale with this model is it gives us an amazing visual platform for understanding and visually being able to recognize how Western harmonies are derived from the scale. In a previous video, I showed what the interval structures shapes look like that create different types of chords. For example, augmented, major, minor, or diminished. So if we just use these shapes using the key, assuming we don't have them memorized, we can just look and, for example, see the do, mi, sol chord that I played earlier, and see that it has the same shape as, well, the major chord shape, and know through that do, mi, sol, without even hearing it, should sound major. This is why this is such a great visual tool for understanding music. We can look at interval structures and know what kind of interval structure they are just by looking at them. We don't even have to hear them. I'm going to give a quiz. Hopefully this quiz is pretty easy. So, do, mi, and sol we saw was major. So, by that logic, what is fa, la, and do? And, I guess while we're at it, what is re, fa, and la? If we're working off of a major scale, and we'll just say for now that this note is do, our fa chord, so do, re, mi, fa, which goes fa, la, do, would be a major chord. Fa, la, do. And our re chord, which would be do, re, and would be re, fa, la, would be minor. If you've studied music at all, you might have taken note to how our model represents inversions. And an inversion is kind of like playing a chord out of order. So, for example, you might play the fa, la, do chord as the notes fa, la, do, but you could also play them as la, do, fa, or do, fa, la. And whichever one of these inversions you choose of it, or whichever one of these orders you put the pitches in, it's still going to have a pretty similar major sound. And what's really cool about this model is you can see that the shapes that represent the inversions vary slightly and are a little bit different as you invert it, but still have some kind of same continuous pattern. For example, the diminished shape always has diagonal movement in the same direction. And as you extend the minor and the major shapes, they always have two pitches connected by a line and one pitch either a hex above or a hex below that line, depending on whether you're working with a minor inversion or a major inversion. So they're still very visually easily identifiable. Here's an example of how these inversions might sound. So the original inversion, fa, la, do, or we can invert it slightly and we get do, fa, la, or la, do, fa. And if we string them all together, we get what's called an arpeggio. What's cool is whichever inversion we do, it's still going to have a pretty similar major sound. The lesson we did today about how harmony is derived from the scale in Western music is a pretty basic music theory lesson, and really just the tip of the iceberg of what we can do. There's a lot of music theory lessons that we can use this model to help us build kind of a mental map of what pitches are doing. And what's really cool about it is the more you learn theory, thinking about how sound is moving through space and what the pitches are doing to interact with each other, the more understanding music becomes a puzzle and becomes about fitting small identifiable objects together to create musical structures. So in the next video, I'm going to go on to show how we can modify the scale and explain certain ideas in theory related to alternative scales that get used a lot in music. But for now, this concludes this current lesson. Thank you.